In this video, you will learn how to find the value of y using a simple logic. This is a polynomial equation because the highest power is 3, but we are going to see how we apply logic in solving this Olympiad exam question. Don't forget to give this video a thumbs up, share with friends and colleagues, and kindly remember to subscribe to my channel before leaving my page. Now let's get started. To solve this question, I'm going to look at a way of bringing 12 to the left-hand side. So I'm going to have y to the power of 2 minus y to the power of 3 minus 12, and this will be equal to 0. So from here, we are simply going to apply a simple logic. From here, you see that negative 12 can be equal to negative 4 minus 8, right? Good. So if we can replace that for 12, that will a bit make sense. Now let's replace that for 12. We'll have y to the power of 2 minus y to the power of 3. So instead of negative 12, we're going to have negative 4 minus 8, and this will be equal to 0. Great. Now what do we have here? We're going to simply see that 4 can be equal to 2 to the power of 2, right? And 8 can be equal to 2 to the power of 3. So to simplify this expression, we are simply going to replace all those with 4 and 8 with 2 to the power of 8 and 2 to the power of 3. So we'll have y to the power of 2 minus y to the power of 3 minus 2 to the power of 2 minus 2 to the power of 3, and this will be equal to 0. Great. Now we're going to collect powers, exponents, variables, or integers with the same variables, with the same exponent. So we'll have y to the power of 2 minus 2 to the power of 2, right? And this will be minus y to the power of 3 minus 2 to the power of 3, and this will be equal to 0. Now grouping these two parts, we'll have this to become y to the power of 2 minus 2 to the power of 2 on one side, and this will be minus y to the power of 3 minus 2 to the power of 3 on this other side, and this will be equal to 0. Now, merely looking at these two different parts, you come to see that it reminds us of two algebraic formula. The first one is a completing difference of 2 squared. If we have a to the power of 2 minus b to the power of 2, this will definitely be a plus b, right? Multiplied by a minus b. Good. So do you remember this algebraic expression? Now recall this. We have a to the power of 3 minus a to the power of 3. This can simply give us a to the power a plus b, right? Multiplied by, but this should come first, second, a to the power of 2, right? Minus ab, the first and second, plus the second what? Square. So from all this expression, you come to see that a is simply y, and then b is simply 2, right? So we're going to apply that into those two expressions. For the square part, we have the square part to give us y minus 2 or y plus 2, which comes first, and then we'll have y minus 2, which comes second, and this will be minus. The next one, we're going to have y plus 2, which comes first, and that will give us y squared minus 2y plus 2 squared. And all this will be equal to 0. Great. Now, looking at these two expressions, you find out that we have two common terms. And what are the two common terms? Y plus 2 and y plus 2. So what do we do here? We're going to bring out those two common terms, y plus 2. So having y plus 2, we're going to divide this whole part by y plus 2. So if we divide this whole part by y plus 2, we're going to have y minus 2 remaining, and this will be minus. Dividing this whole part by y plus 2, we're going to have y squared minus 2y plus 4 remaining here, and all these will be equal to 0. Great. Now let's expand the inner part. We're going to have y plus 2, and this will give us what? Y minus 2 minus y squared plus 2y, and this will give us minus 4, and all these will be equal to 0. This is going to give me y plus 2 on this side, and then we are going to have negative y squared, right? While this will give us plus 3y, right? While this will give us minus 6, and all this will be equal to 0. So from this expression, the product zero product rule, we will see that we have the first case as y plus 2 equal to 0, and the second case as if we multiply through by negative, when we multiply through by negative, we'll have y squared plus 3y minus 6, and all this will be equal to 0. So we're going to have this to become y squared minus 3y plus 6 will be equal to 0. So from these two expressions, we can find the values of y. So from here, we'll see that y plus 2 is equal to 0. So the value of y will be equal to negative 2. And that is the first solution to this expression. Now let's consider this second expression. Considering this second expression, we're going to look for two values we can multiply that will give us 6. Of course, it's going to be 3 and 2, right? So if we multiply these two values, they are going to give us 6. But can the addition of these two variables give us 3? It's not possible. So that means definitely we are thinking that the solution to this will give us an imaginary solution. Now, how can we do that? The best way to find out that is to look for the discriminant. From that expression, you see that your A is equal to 1, your B is equal to negative 3, and our C is equal to 6. So we're going to look for the discriminant of that quadratic expression. The discriminant will be equal to b squared minus 4ac. Now, if the discriminant gives us the negative value, that means the solution would definitely be an imaginary solution. So this will give us negative 3 squared minus 4 multiplied by 1 multiplied by 6. So what would the discriminant give us? The discriminant will be equal to 3 minus 3 square is going to give us 9, because minus times minus will give us plus, and then 3 square will give us 9 minus this is going to give us minus 24. So the discriminant will be equal to 9 minus 25 is going to give us negative 15. Voila! Negative 15 is less than 0. So that means the solution that will come out from that quadratic expression is definitely going to give us an imaginary solution. So what do we do? I want you to use the quadratic formula at your spare time, solve this, and then tell me what the two imaginary solutions for the value of y will be like. But for now, the only real solution we have for this solution is y equal to negative 2. And that is the only real solution that satisfies that polynomial expression given to us up there. Now we want to check to find out if the solution negative 2 is actually correct. We are going to insert that into that expression, and if we insert that into the expression, we're going to find out if that solution is actually Right. From the initial solution, we are given the value of y to the power of 2 minus y to the power of 3 to be equal to 12. So if I insert the value of y equal to negative 2, will it give me 12? Let's find out. This is going to give me negative 2 all squared minus negative 2 all to the power of 3. Now, will this give me 12? Negative 2 squared is going to give me minus 2 multiplied by minus 2 minus, this is going to give me minus 2 multiplied by minus 2 multiplied by minus 2, and that will be negative 8. While this gives me 4, this is going to give me plus 8. Is it equal to 12? 8 plus 4 is 12. So that is equal to 12. So that confirms that the value of y equal to negative 2 is truly the right solution that satisfies that polynomial expression that is given to us up there. I know you did enjoy watching this math solution. Don't forget to give it a thumbs up, share it with friends and colleagues, and remember to subscribe to my channel for more simplified mathematics solutions. Thanks so much for watching, and bye bye for now.